Hi folks, so in this video what we're going to be doing is the 2014 Leaving Cert question. It's actually from section B, question 2. You can see here it says B2. So it says here, I'm just going to zoom in on the question. As always, read a bit of information about the question before we get started. So it says here, figure B2 shows an incomplete trimetric projection using the axonometric axes method. Now, trimetric basically means that the axonometric plane that we have here, the angle between the x, y, and z are all different. Okay, in isometric, every one of them will be 120. In dimetric, you'd have two angles that would be the same, maybe 110 and 110. But in trimetric, all these angles are different. And you can see here, they only tell us one of them, which is the one between the y and the z, which is 110. So it says here, I'll just start it again, shows an incomplete trimetric projection using the axonometric axis method of a model of a basketball backboard based on the 3D graphic on the right. So we've got a 3D graphic here, and based on the problem down here, I assume we just have to draw this portion of it here, not to include the hoop. Okay, it says here, part A, draw the axonometric axes x, y, and z, and the scalene triangle ABC. So that's the first bit we'd have to do. Then part B, draw the elevation and end view, or end elevation, orientated as shown, and complete the trimetric projection. Part C, we'll get on to the end of the question, usually a part there. If you get two of these done, this is going to be the part where you kind of get the A in the question, okay, if you've done really well up to this point. So, part A, draw the axonometric axis x, y, and z. So let's look down here. Based on our drawing, you can see the y-axis is a vertical line, okay, and then the z-axis is 110 degrees away from that. Okay, so really easy to get the y and the z. The problem is the x-axis, which is a little bit tricky because they do not tell us the angle here between the y and the x, and they don't tell us the angle between the x and the z. So is there anything else we can use in the drawing that will help us find the x-axis? Yes, there is. If you notice down here, we have a line for the axonometric plane ABC. We have a line AB. They do tell us the length of that line A to B, which is 90 millimeters. Now, what's important to note is if we can find that B point, because note that B is on the x-axis, well then, if we have B, we can find the x-axis. So, if you look at the y-axis, if I extend that straight down, and from the y-axis where it comes down, you can see here, from the y-axis, it's 50 millimeters away to where it cuts the z-axis, which gives me A. And once I have A, I can measure 90 to the right from A to find the B axis. So that's how I'm going to actually find the x-axis there. So let's look at the drawing here. I have a little bit already done. I had already put in my y-axis, positioned slightly to the left of the middle of my page, okay? Here is obviously the origin, and I've done the z-axis, which is an angle in there of 110 degrees. Now, what I've done is I've I've extended down the y-axis, and from anywhere down here, I just did a horizontal line across, very lightly, like that. And from this point here, I measured 50 millimeters into this point right here. Now, from that 50 millimeter point, I'm just going to do a vertical line there. And what I found right there where that point cuts through is my A. So if I found A, I know distance of B away is about 90 millimeters. So from A, you can see the distance from A to the center is 50. Happy with that. And I want to add on another 40, which would bring me to 90. That point right there is my B, which I can now draw in to create my x-axis. So at the higher level, they'll throw little tricky things at you like that. So that's my x, and most importantly, I've now found B. Okay, so the next thing we have to do is we have to find the C axis. Now, to find the C axis, that is going to be, the C point, not the axis, that is going to be a line that is going to be perpendicular to this x. So I'm going to extend out my x line there like that, using sliding set squares. I'm going to go perpendicular to that x line from the A. And that then will help identify to me where it cuts through the y-axis up here. I have now found C. Okay, while I have it positioned, I'm going to extend it out just to get it ready for the part B of the question. Likewise with it down here. Okay, now I'll connect up B and C as well. And what you'll notice is that line there is going to be perpendicular to my z-axis. So, just going to extend these out a little bit further, just a touch. This one here. You don't have to use sliding set squares. And then perpendicular to those, set up this guy right here. Okay, should extend that on a touch further. Okay, now what I want to do is I want to set up my 90-degree angle inside here that's going to hold my end elevation, which we're seeing as a line in this view. So to get that, with this edge here, or with this face, or this line I should say, sorry, going to bisect that line. It was working. There we go, finally. Bisecting that line. Now got the middle of that line. Having got the middle, I'm going to do a semicircle. Okay, happy with that. Extend that out here. There I have my 90-degree axis. Now what's important to note is this is a point view of the x-axis, and this here is my z, and this is my y. Now, if I just zoom in here, I do not know the height of my end elevation, which we're going to see just as a line in this view over here, because the end elevation is looking in at that side of it there, which we would just see as an edge. So I do not have the height of that just yet. So I'm not actually going to put that in until I complete this view over here. So this is the next view we're on to. With part A done, okay, we're on to part B. Draw the elevation and end elevation or end view orientated as shown and complete the trimetric. So essentially what they're asking us to do is get this view, and then get the trimetric inside here. And you can see it's been partially completed, missing the curve, maybe missing the box section in there. Okay, so that's what we have to do. I kind of have this one done. I'm now going to move on to this view over here. So, following the same rules that we've applied previously, using my x-axis as a guide, I'm going to extend that line out. Also going to extend out to B. And then finally to C. You can see how I'm just using the set squares together in tandem. Then from up there, if I rotate it like this, I'll now be parallel to BC, but what's more important is I'm perpendicular. I'm going to come out a good bit, come out to about here I think, should be appropriate. Hopefully that will work. Like we did over here, where we bisected our line, we're now going to bisect this line. Just pick a distance greater than halfway. So I've now found the middle. Once again, semicircle. Just check your accuracy always, yeah. Happy with that. Worked out a little bit better on this side. And now from where the z-axis runs through, intersects the semicircle right here. We connect that to the diameter end over here. And then the diameter end over here. As we know, any triangle inside of a semicircle that meets at either end of the diameter, and then any point in circumference will be 90 degrees. Okay, so there is my axis kind of set up. Once again, this point here would be a point view of my z-axis. I've got my y, and in this case, I've got my x. Okay, So how do we draw this? So let's look at the object here. They do not, once again, tell us the height of it. They just give us a h. They do give us some heights. They tell us the height of 10. They also tell us the height of 40. So I can measure up, obviously, 10 here and 40 here. Do they tell us the radius of the curve? No, they don't. They just tell us, I suppose, r for radius. And then do they give us any other, I suppose, information about the object? Yep, they tell us, obviously, we have a square inside here that is a length of 40 and a height of 40. So I got that square to get. But is there anything else I noticed about it? Okay, if you notice here, where they have the semicircle, okay, that's actually right here. This point here, right there on my sheet, if I just zoom out, where we can see R1, semicircle here. I've obviously got my semicircle here. This point here is here. So I've actually got the center point of my arc. Now, you can actually see the distance from here to here, okay, is actually going along that line there, which is here. So that distance from there to there looks like it's symmetrical. That means the distance from there to there is the same as from here to here. So this distance is equal to this distance. And I have that distance. So what can I do? I'm going to have to just step it out on my sheet out the opposite side. And then, so they do actually give us the length. It's just a case of actually having to find it. So they won't always just give it to you straight away. You might have to use a little bit of your own understanding. And in this case, I use the principle of symmetry. So extend out this line. I'm now going to take the distance from here into this point here. Just mark it out the opposite side. Okay. I'm now going to put in my heights. I have a height of 10 and 40. Which altogether adds up to 50. So from the 50, I'm just going to mark backwards. So there's the 50, 40 up and 10 up. Now using that as a guide, I've also got, you can see here, 40, which means from the middle, go 20 to the left and 20 to the right. So from the middle, 20 to the left and 20 to the right. 2, 3, 4, 5, 6. Actually just mark it from 5 to 7. Go. Then a little bit of sliding set squares. I made a mistake there, apologies. Should have marked 10 here, not up there. So the one I didn't want is this one. Let's put a little X beside that. Now, a little bit of sliding set squares. Start building our object. Line like this. I don't need that one. Line like this. Now I'm going to do a vertical line. So you can see how I'm using the set squares together to create a perpendicular angle. Okay, so now I can start heavying in information. So this is the side face. And now heavy in this as well. Okay, and the next little bit, I suppose, is have I got the center point? Yes, I do. This point here, which is here. And have I got this point, which is on the curve? Yes, which is over here. So just to test it out, I would always check that this one here, hopefully, if I'm accurate, should match up with this point over here. And yes, it does. So I'm happy with that. Now put in that curve. And there we go. That there is now the, I suppose, elevation completed. And I'm now going to finish off the end elevation because now I have the vertical height. So just to get the vertical height, take it from the middle section. So it's the height from here down to here. I'll now take that distance on my compass. And I'll mark it up over here. Okay. So there is the end elevation. And while I'm at it, I'm going to put in the height for this point, which is 10, and then up another 40, because the heights will be transferred across. So 5 up to 4. Use this one actually. There's the 10, which will give me this height. Then I have another 40 to give me up to this height, which will be there. And then obviously that section from there to there is the curve. Okay, so I want to start actually building that object. So what am I going to do? I'm going to start projecting parallel to the axis. So every point over here, let's use this one. So parallel to this line here, or in this case I should say parallel to the Z axis. Apologies there guys, the lights are starting to go out here, so I'm just going to move again just to get them on. I'm just censored. There we go. So parallel, as I said, to the Z axis. Now I'm going to project over my points. So bring this one down. I'm going to bring this one. They'll all just be on this line here, this surface. This one. This one should be right there. Okay. Slide it over again. So get some further ones back up here. You can see how I'm using the set squares. Be along there somewhere. I'm going to have one here. Now bring them down one at a time if you get confused. And then finally this one. Okay. Now what I want to do is I'm going to bring down parallel to my x-axis. This one here. And just make sure, yep, I have that. And then also this one. So that'll be that one, happy with that. And then should be hitting, just check about there. Yep, quite happy with that as well. Okay, so let's start building the object. This point here, which is coming from this height, it's going to be right there. Then it's going to connect down to this one, which is on the ground, so it's down along this line. So that's that one. I can heavy it up to here. I can see that my points are matching up, so that means my accuracy is actually good. Then it goes heavy over to here. And then it's heavy up to this point, so it's down along this line. So let's see where they meet. Yeah, they meet right there. Okay, then this one goes upwards. So let's find it. It's right to here. Now that should be a vertical line. And if you want to test your accuracy, you can always just bring your T-square on. And actually slightly out. Oh. There we go, just slightly out, not too bad. Okay, and now the next thing I want to do is I want to get the square inside here. So let's find the bottom 2 points coming from this height as well, because you can see it's on that height of 10. So from here, so there's one, there's the other. So I'll heavy that in. Now these lines go vertical, so they should be going straight up. Not bad. About a half a mil out. That one's a bit closer. And then this one right here. Okay. So there we have that, guys. Now what we want to do is we want to get the curved portion. So I think the best way to get the curved section is we're going to use ordinates, okay, and we're going to use horizontal cutting sections to cut along this. So from the top, I'm actually going to measure down. Or I measure up from here. I think I might actually measure up from this height. I'm going to go up in 5mm spacings. So, no, do you know what? I'll measure down. Makes no difference. You can measure down from the top or up from here. So from the top, I'm going to measure down in 5mm increments. So 5, 10, 15, 20, and 25. Now, every one of those little marks that I've done there, obviously you'll be using a pencil on the day, makes it a bit easier to keep your accuracy. There we go. I want to do horizontal cuts across here. So there's 1, 2, 3, 4, and finally 5. Now every one of those I'm going to mark with a number. 0, 1, 2, 4, 5 into 6, all the way around the other side, 7, 8, 9, 10, 11 to 12. Okay, same principle has to apply over here. I'm going to measure down in 5mm increments. So 5, 10, 15, 20, finally 25. So marking up from this side, I have 0, 1, 2, 3, 4, 5, 6, back down 7, 8, 9, 10, 11, and obviously back to 12. So just to find those points, same method, project them down here and down here. So I'll bring all these ones down first, so it'll be a little touch easier. So I want to make sure that I'm parallel with my x-axis or any line that's been going previously. So there'll be 1 and 11, 2 and 10, 3 and 9, 4 and 8, 5 and 7, and finally number 6 at the very top. Okay, so they'll be all down there somewhere. Now I'll do the same principle over here. So I'll do a number and number. I'm going to start with number 12, which is already got for me. I'll just use it as a guide. So there's number 12. So start with number 11, which is this one down here. Just make a little mark on it. Next one on be number 10. There's my next mark. You can see here if I follow it back, there's number 10. On to the next one, which is number 9, which I'm assuming is this one here. Just checking back to be sure. Yep. Next one is going to be number 8. Once again, check all the way back. Yep. Want to be certain. Yeah, I'm happy with that. Next one is number 7. And finally, number 6, and I can work my way down then. 6 is at the top. It's probably the easiest one. And now I'm on the way back down. So, on the way back down, got number 5. And I have number 4. You can see here 4 and 3, they're so close. Use the same line. Extend it out. There's number 4. Number 3. I'm on to number 2 now. It's very close as well. Just a bit further. So there's number 2. And then finally, number 1. Now you can see here, my biros aren't probably the best thing to be working with here. We'll make do. So what I want to do then is I found all the points. I want to use those points to sketch in my curve. When you get to the top, see here the distance is kind of greater on this side between the points. There you go. Once you're happy with the curve, and sketch it in. There we go. That there is the elevation, end elevation, and axonometric completed, where we did, in this case, I think it was the trimetric. So that's part B done. Okay. So now the last part of the question, it says here, draw the axonometric projection of a basketball in contact with the backboard at the point P. Okay, so let's locate the point P. We can see it's over here. So just to be able to find that in my drawing, I would then connect this guy here, and hopefully it'll meet in the middle. Yeah, happy with that. So right there is our point P. And what it's asking us to do is draw the axonometric projection of a basketball in contact with the backboard at the point P. The radius of the ball is 12 millimeters. Okay, so what they're asking us to do essentially is draw in a basketball that is touching the backboard at point P. Okay, so first of all, I'm going to locate point P in all views. So to locate it down here, I would then have to locate it over there. So first of all, the height of it, it's quite easy to find it over here actually first, sorry. I'm just going to use my compass. I'm going to take the vertical distance from here to here. Zoom out there. I'm going to take that distance there. And I'm going to mark it up over here. So there we have it. That point there is point P. Now that I have it in two views, I can find it in my axonometric. Simply a case of using sliding set squares. So for the P in this view, it's going to come down here. And then parallel in this case to my x-axis, or z I should say, sorry. And what's important to note is right there, that is where the basketball is in contact with the board. Does not mean that is where the center of the basketball is. That is where the face of the basketball hits it. So to see where it's actually in contact, we need to see the board as an edge view. And technically, this face here of the board, when we're seeing it side on, is an edge view of the board. So the easiest way to do this is from the point of contact, which we are technically given, because that's where the basketball touches the board. I'm going to go perpendicular from the point of contact, okay, out there, and it tells us draw the axonometric projection of a basketball in contact with the backboard at the point P. We've got the point P. It says the radius of the ball is 12 millimeters. So from P, it's very easy. I can measure out 12 millimeters. Just up to there. The radius is 12. That means the center of my ball is right there at that point. Out 12 millimeters. Just to mark it a little bit clearer. And then what I'm going to do is I'm going to draw in, as best I can, a circle which will represent the basketball in the end view. There we go. So that's the basketball in the end view. The basketball in this view would simply share the same radius, or same point, center point I should say, with point P. There we go. That would be the basketball in the elevation. And then finally, to locate the center down here and get my basketball in my axonometric, I need the center of the basketball. Slipped a little bit. Need the center of the basketball to come down, and I need to project out my P line from my elevation. And this point right here, where the two of them cross each other, is the center of my basketball. And just make sure I have the same radius, because it does not matter what view it is in. A sphere in isometric will always appear still as a circle. There you go. There is our basketball drawn in our axonometric. Okay, That is the basketball when we see it from the side. That is the basketball when we see it from the front. And as you can see here, this is the basketball when we see it in our axonometric view, okay, over here. And you can see it looks the exact same as our 2D views over here. Because it is a sphere, it does not matter how you position it, okay, in 3D or 2D, it will still appear as a circle. Okay, so that's the part C1 done there. Draw the axonometric projection of a basketball in contact with the backboard at the point P. The radius of the ball is 12 millimeters. That is the question done. So that, guys, there was the 2014 higher level axonometric question. The part C part there is the tricky part, but if you just think of it, I suppose, think of it and just break it down into simple steps, okay, and just try and think of it analytically, okay. It's not hard. They're just trying to confuse you with some of the kind of wording of the question, okay. So that's 2014 axonometric question done there, guys. I hope you found that helpful. Okay.